All right, so I wanted you guys to see a GeoGebra sketch talking about the graph of sine of x and its derivative. So earlier on, we know that the derivative of sine of x is cosine of x, but this really helps us tell why. Now, if you could take a look, they tell you what the slope is at each point, and that really what that is it's the instantaneous rate of change. It's the derivative at that point in time. Now notice, and this isn't sitting perfectly, but at pi over 2, the slope is 0, right? We have a rounding error there, but the slope is 0. At pi, we have a slope of -1. At 3 pi over 2, we have a slope of 0 again. And at 2 pi, we have a slope of +1. Now, ultimately, that should seem pretty familiar to you guys. And if we were to start to plot this as we go along that curve, and what we're doing is we're just plotting the y-coordinate as the slope. So we're finding the derivative. We're plotting every single point of the derivative as that slope continues through. And as we plot each and every derivative point on here, right, the curve should start to look a little bit more familiar. And we start to see that cosine curve. So as you can see, that red curve is our cosine, right, a really nice cosine curve. And that's just simply being found by plotting each and every slope of the sine function. When we're talking slope, what slope is really referring to is the derivative. So over and over again, we've been talking about how the slope is the derivative. And in this case here, we can actually see that the cosine function is the slope of the sine function. So it's kind of a odd thing that you've probably, that you've been seeing for a long time, but didn't even know what you were seeing. So just another way to show you guys why the derivative of sine of x is cosine x. It's literally the slope of the function sine x.